All right, guys. So we are going to do notes 28, just this first top part here, this first page. Tomorrow we're going to do this chunk of notes 28, and then let me move me out of the way. And then lastly, I don't think it's the next day we'll practice it, but then the last set of notes will be this little section. So if you notice, today is the longest note day of the week, and then it's just little chunks after that to kind of add on to it. This is kind of like the meatiest part of the notes this week. This is also the last thing you have to know for the year is this week's notes, or yeah, for the year, because then you'll be leaving off and we're doing midterms the next week. Okay, so let's do naming compounds. Again, I want to reiterate that the only hard part, or the hardest part about doing naming compounds or writing chemical formulas for compounds, which is what this entire unit is all about, is you have to be able to know the difference of when you're doing an ionic compound. Why is it not writing? My smartboard isn't on. Oh no. 1 second, guys. I'm pretty sure this will fix it, hopefully. Hold on, plug in. Hope so. So you have to be able to know when you are dealing with an ionic compound versus a molecular. So today and tomorrow, we are just going to be focusing on ionic compounds. And being that you have already learned the rules for how to write the formulas, this is really just going the other direction, just kind of doing it backwards. So you should have kind of already heard this stuff before. We're just putting it together now. So today we're just doing binary ionic compounds. Bi, like di, means two. So it's just going to be 2 element compounds, but they're ionic, so it's a metal with a non-metal. That's how I can tell them apart. Keep looking on the end. Non-metal, and it's a positive with a negative charge. That's what they're doing. It's the only thing that's going to be named like this one, or like these ones, okay? All right, so I'm going to hide this button. There we go. I'm going to scroll down so we can get all of the notes in one fell swoop. There we go. All right, so you just have these short set of rules, and we're just going to use them to name these 2 element compounds that are all a metal with a non-metal. Okay, the first rule says if the first element is a metal, which it almost always is, it's only not going to be on tomorrow's notes because ammonium, which is a polyatomic ion, can sometimes be first. But every other time, it's going to be a metal first. So if the first element is a metal from groups 1 or 2, remember that is on the periodic table, groups 1 or 2. Draw a little mock periodic table here. Wow, it's uncalibrated again, as always. It's these 2. So these 2 rows, right here and here. If the metal is found in those 2 rows on the periodic table, then you literally just name it as is. Don't do anything to its name, just write it. So if you don't remember how to spell it, then of course you have to go look it up by its symbol. But as long as you've looked it up, you just write down its name. Do nothing else to it. So I'm going to go find Ca in the metal section. It is in groups 1 or 2. Ca is in this second column here. So I'm just going to write its name. Calcium, like that. Done. Okay, so I just wrote his name. Now, the next rule I'm going to skip to finish this is name the second element, changing the ending to I. You've been seeing that non-metals always change their ending of their name to I. So sulfur on the periodic table is now going to be sulfide. Okay? That's it. That's the end of that name. It's calcium sulfide. I'm going to write it so it fits better in the line. Calcium sulfide. So if the metal is in the first 2 columns in the table, it's literally just write down. And the non-metal that was sulfur, I change to sulfide. Done. Okay, let's choose one that doesn't follow just those 2 rules. It uses the second one. Okay, so it says if the first element, here we go, copper, if the first element is any other metal, so any other metal that isn't in the first 2 columns on the periodic table, then it must have those Roman numerals that represent its charge. So this is what makes it difficult, is because you're going to have to figure out its charge. you don't actually really know it, and you're going to have to figure it out using a little bit of backtracking math, okay? I'm going to calibrate this really fast. I feel like it's just a little too off. Okay, so how we do that, how we're going to figure out its charge. Remember, these are exceptions to the rule. Silver is always +1, cadmium is always a +2. I'll write those up here. Okay, so we'll add it to your notes. +1, +2, zinc is always a +2, and aluminum is always a +3. So even though those are metals that are in the middle section, they actually don't need Roman numerals. All the rest of them do. Okay, so I'm going to look up Cu on the periodic table. It's in this middle section, so it does need Roman numerals, but I can go ahead and write its name, which is copper. Okay, since I know it's going to need Roman numerals, I'm going to go ahead and put in those parentheses where those Roman numerals are going to go, and I'll come back to it in a second. The second element is still that third rule. It says name the second element, changing the ending to I. So I look on the periodic table, I find Br. Br is called bromine, so I'm going to change bromine to bromide. And there we go. Let me make that, again, fit on the line. I'm just starting off too big on these. Copper, parentheses, because I'm going to have to put those in a second, and it's going to be bromide. There we go. Now, we have to figure out what those Roman numeral charges are going to be. Copper can be a lot of different charges, so I'm going to have to figure it out based on what the compound formula shows me. So how we do that is you backtrack with charges. Again, I'm going to look at bromines, because I don't know coppers, but I know bromines. If I look at bromine, it's in the 17th column. It's right here. It should be a lot longer. Okay, if you like here, it's in this column and it makes a -1 charge. So you literally just look at your periodic table, you see what charge it makes. Bromine means a -1 charge. Now in this formula, there's only one bromine. So there's only one atom of bromine that has a -1 charge. There's also only one atom of copper. So something has to join with bromine's -1, and all compounds want to balance to 0. So what plus a -1 balances to a 0? Well, a +1. +1 minus 1 equals 0. So that copper had to be a 1 charge to balance a bromine. If it had any other charge, it wouldn't balance to 0. So that copper had to be a 1. So that's what I mean by backtracking, is I know bromine's charge is a -1. So what does copper's charge have to be to balance that compound to 0? All right, let's do one like that again. So copper, again, we already know where copper's at. It's in the middle of the table. So being it's in the transition middle section, it's in the middle of the table, I know it's going to need Roman numerals in its name. But now I have a new non-metal. So again, the second element, still rule number 3, second element, I'm going to change its name to I at the end. So I find O on the table. O on the periodic table is oxygen. So it becomes oxide, like that. But I need to figure out the Roman numeral charge. I don't know coppers. That's the point. I have to figure it out. But I know oxygens. Oxygen is in the column next to bromine, and it makes a -2 charge. So if it makes a -2 charge, and again, I'm looking at this formula here, there's only one oxygen. So that means there's just one atom with a -2 charge. There's also only one copper. So something plus -2 had to balance to 0. Well, again, a +2. A +2 minus a 2 equals a 0. So this copper had to have a +2 charge, or it wouldn't have been able to balance that oxygen. So now you see, these are both the same element. They're both copper, but the metals in the middle can make varying charges. Sometimes copper makes a +1, sometimes it makes a +2. If we look at other ones, sometimes iron makes a +3, sometimes it makes a +2. So you have to figure them out. That's why they are named slightly differently, because their charges differ, and we have to tell the reader by their name what charge this one actually has. Okay, let's do another one. Go back up to this easy one. I look at aluminum. I notice that in my rule number 2, it says aluminum is an exception. It doesn't need Roman numerals. So then I just name it. Al is aluminum. Don't change it. Just write down its name. And then I go to rule number 3 that says name the second element, but change its name to I. So I look at the periodic table. F is fluorine. So now it's fluoride. Done. Okay, so that one's finished. Let's scroll down to here. So we have Ag, which on the periodic table is silver. Again, I think that's in the middle section. It's like over here. Silver's in there. So I'm thinking I need Roman numerals. But then I check my rule number 2, and rule number 2 says that Ag is also an exception, just like aluminum was. They were both exceptions to the rule. They do not need Roman numerals, so you literally just name them as they are, silver. So then I skip down to rule number 3. It's always the last one you do, and I change the ending of that second element to I. So S on the periodic table is sulfur, so that becomes sulfide, and that's it. So silver sulfide. Okay, so the next ones are going to be a little more tricky. We're going to figure out their charges. All right, so I look at the Fe, I figure out where it's at. It's in the middle section. It's not one of the exceptions to the rule, so it does need Roman numerals. Fe on the periodic table is iron. So I know that's its name, and I leave it the way it is, iron, but I know I'm going to need Roman numerals to represent its charge, and I'm going to have to figure out its charge, because that's the whole thing, is like, I don't know what it is. That's why I need Roman numerals. Now, O, we've already done before. O on the periodic table is oxygen. It's the second element, so I'm going to change its name to I, so it becomes oxide. But I need to figure out the charge. On the periodic table, I know oxygen's charge, but I don't know iron, so I'm going to compare them. Oxygen on the periodic table is a -2. Now, here's the first time this has happened. There isn't just one oxygen, there's 3 of them. So it's actually 3 atoms that all 3 of them, that all 3 of them have a -2 charge. So there's a -2, a -2, and a -2. Well, that totals to a -6. There's a total negativity in this compound of a -6 charge. And the iron only has 2. There's 2 irons. Something plus something. So 2 atoms with some charge have to balance out that whole -6. So obviously, it has to add up to a +6, because we need a +6 minus 6 equals 0. But I only have 2 spots. So what 2 numbers add up to a +6? If they're both a +3, +3 plus 3, then +3 plus 3 is +6, -2 minus 2 minus 2 is a -6. So then +6 minus -6 equals 0. So this iron needed to be a 3 charge. Each of those irons, because there's 2 irons. It was Fe2O3. There were 2 irons in that compound, and they both had a +3 charge, and that balanced out the -2 charges of the oxygens. All right, there we go. Let's try another one. So Sn, I'm going to look up. Sn on the periodic table, again, is over here in this middle section. So I don't know its charge. I'm going to have to figure it out. Its name is 10, though. So I know it's 10, but I know it's going to need Roman numerals because it's in the middle section. It's not in groups 1 or 2. The second element is phosphorus on the periodic table. P is phosphorus. But I know with my rule number 3 that I'm going to have to change its name to phosphide. So phosphorus becomes phosphide. Now, I will remind you that the way you know where to take off the ending of the non-metal's name and replace it with I, let's give you an example of phosphorus. So phosphorus, okay, that's how you spell phosphorus. How you know is you cut it off at the second vowel from the back. So here's the ending. I'm going to go back to vowels. So A-E-I-O-U, those are our vowels. So here's the first vowel, here's the second vowel. So that's where you make the cut. All of this gets cut off in the name, and then I just tacked on I. So see how phosphor became phosphide. That's where you make the cut. Now, to be honest, if you mess it up a little bit and misspell it, I'm not going to count off much for that. If you remember to change the ending and change it to I, that's close enough to me for the most part. So as long as it's close, I'll get what you're trying to say. I'm not that worried about spelling, but that is the general rule, is you cut off at the second vowel. Okay, so back to what we were doing. We need to figure out these Roman numerals. On the table, I know phosphorus's charge is a -3. But this phosphorus has 4 of them. There's 4 phosphoruses, and they each have a -3 charge. Every phosphorus has a -3 charge. So -3, -3, -3. Well, that totals to how much? A -12. I have a -12 totally going on in this compound, and I need to balance that. The 10 has to balance it to equal to a 0. Now I know what plus a negative 12 is 0. It's going to have to be a positive 12. These 10s are going to have to totally be a positive 12 charge. But there's only 3 of them. There's 3 10s. There's something, something, and something are going to have to add up to be a positive 12 to balance out those phosphorus negative charges. So what plus what plus what gives me a plus 12? Think about it. You can always just divide the number by how many things you're looking for. I need 3 of them, so it's 12 divided by 3, which is 4. So plus 4, plus 4, plus 4 totals up to be a positive 12. So each of these 10s had to be a plus 4 charge. Okay? Now notice this time I didn't put the little top hats on. You technically don't have to put the bars on it. I won't count off. I don't care that much if the bars are on it or not, especially if y'all are virtual and you're trying to figure out how to type a Roman numeral. You can just type a capital I and a capital V, and that looks fine. The bars on top and bottom aren't necessary. Just some people write them with the bars, some people don't. Doesn't really matter. All right, so that is what 4 Roman numerals is the I before the V, and there you go. It's 10,4-phosphide. Okay, last one. We look up, we have zinc. All right, so I know that Zn is zinc on the periodic table. That's its name. And I think about it, is that in the groups 1 or 2? Nope, it's not one of those. But, yaha, it's in the exceptions to the rule column. So it doesn't need Roman numerals. Yay! So no Roman numerals. I just get to skip to the second element. The second element, we always change it to I. So I find N on the table. N is nitrogen. So nitrogen becomes nitride. Again, how I know where to make the cutoff is I think about its name and I cut it off where it has 2 vowels. So this is the first vowel, this is the second vowel. That's where I make the cut. So nitra, then I tack on the I, nitride. And there you go. So that is how we do ionic naming just when it's 2 elements. So tomorrow we'll do it when it has the polyatomic ions added in there. But today it was just a metal with a non-metal. How do I name it? Remember, if it's just a metal in the first 2 columns, it's super easy. Just put the metal's name, change the non-metal to I. It's only difficult when it's a metal in these middle sections and you have to write their charges above it and figure out what its charge is by working backwards. What charge does this one need to make it become a 0? All right. Push pause there. Tomorrow we'll add on the polyatomics.